1.5, multiplication with whole numbers and area. Multiplication as repeated addition. If we're multiplying 4 times 400 using repeated addition, what we're saying when we say repeated addition is the repeated addition of the 400. So 400 plus 400 plus 400 plus 400. We would say 400 plus 400 is 800. And we could group the other one as well to get 800. Adding those together to get 1,600. Now some of you in your head were thinking, well, I know 4 times 4 is 16 and then the 2 zeros. Yes, but we want to use that repeated addition pattern so we can use it and apply it to other areas of math. So repeated addition is taking this set, this number, and breaking it into 4 sets. Or you could do 400 times of the 4. So like you could do like 4 plus 4 plus 4 plus 4, 400 times, and you would get 1,600. We're going to do the same thing. We know 7 times 7 is going to give us 49. So it'd be 49,000, but we're going to show it using repeated addition. Remember, we need to do the 7,000 7 times because that's what makes sense. So we're going to start all the way on the far end of our notes. And we have 7,000, 1, 2, 3, 4, 5, 6, 7. And we can group them however you want to group them. I'd like to group them as big as possible, so I'm going to add the first 3 to get 21,000. Add the second 3 to get 21,000. And then add 7,000. I don't know why that sounded the best to me, but I know 7 and 7 is 14, so you could do groups of 14, 14, 14, and that might be easier for you. But I know 7 plus 7 plus 7, 7 times 7 times 7, 7 plus 7 plus 7, like I said before, is 21,000, or 21, and then you add the zeros at the end. Just so you know how I'm thinking about it in my head, I'm again thinking about the 7, the 1, and the 1, those 3 numbers, to get 9. I know the 3 zeros at the end, so I'm just going to have that, and 2 plus 2 is 4, to get 49,000. I need that space. Okay, vocabulary. So multiply, a product, when we use the word product, it means to multiply. Other words and symbols that indicate multiplication, we know the word times, multiplied by, double, of. This is a really magical word here that kind of shows up that later on math, and we use of a lot. Multiple. We use symbols like 3 and then a dot in the middle, times y. Sometimes we don't use any symbol, like 3 times y. Or we use 3 times y, like an x. Or we even use 3 parentheses, I'm going to use a number this time, 4, that means multiply. Factors is another multiplication term. Factors are numbers that when multiplied together give a product. We have lots of different examples. This is a huge algebra piece, so we want to make sure we understand. If we say the product of 2 and 5, we would say 2 times 5. These, each of them, are factors, and the product is 10. So identify the products and factors in the statement 9 times 8 equals 72. We would say 9 and 8 are factors. That's what's being multiplied together. And 72 is the product. In the next one, 30 equals 2 times 3 times 5. 30 is the product. And in this case, we have 3 factors, 2, 3, and 5 are factors. Let's look at distributive property. Distributive property is distributing a number to 2 numbers but keeping the same original solution. So we're going to look at 2 different sets, and I'm going to explain what it is that we're doing here. So in problem 1, they did 4 plus 5 to get 9, and then they multiplied, so they did parentheses first, and then they multiplied 3 times 9 to get 27. The distributive property is in example 2. So you might see something that looks like this. 3 parentheses 4 plus 5. However, instead of adding these 2 numbers together, we're going to distribute and we're going to multiply in the process. So 3 times 4, and then do it again, 3 times 5, putting the addition sign in between them. So we're going to do 3 times 4, addition sign, and then 3 times 5. That's what we get here. And then they multiply. 3 times 4 is 12, 3 times 5 is 15. Add them together to get 27. This may seem like the easier way to do it, and it will be until you add in a variable, and then you have to do it. So you really want to make sure that you're focusing in on this lovely gal over here, or sir. You want to focus in on this way of math because eventually numbers start to disappear. Let's look at the next, these are properties. So in this case, we want to make sure that because we're multiplying, we're talking about the multiplication properties, that you understand that these are all multiplication pieces. So notice it says multiplication property of 0. Multiplication by 0 always results in 0. So 5 times 0 is 0. You could say a letter like A times 0, and it will also be 0. Anything times 0 is 0. That's the multiplication property of 0. The multiplication property of 1 is multiplying any number by 1 leaves that number unchanged. So it remains the same. So 1,203 times 1 will give me 1,203. Here's where it starts to get more interesting. Remember we talked about in 1.2 the math associative properties for addition. Now we're talking about those properties in multiplication. The commutative property of multiplication is when the order of the numbers in the product are switched, but it doesn't affect the result. So again, remember that commutative means that we're moving numbers around. So if we had 3 times 5, notice the multiplication sign is now 5 times 3. Associative property of multiplication, we're going to change the grouping. Remember, that's the one with the parentheses of the product without changing the result. Associative property is going to be the one of multiplication. Make sure that you understand when we're talking multiplication, if I have like 5 times 1, that's the point that I was trying to make. 5 times 1 times 4 you stay the same in the same place value. So 5 times 1 times 4, same order of the digits. You're just moving the bracket. And what I was trying to say before I slipped on my words, you want to make sure that this is all multiplication. This is all multiplication. You're not mixing your operations. So it's not going to be addition and multiplication or addition and subtraction. These properties are used when most of the time all these things are just multiplication or just addition. Until later on when you talk about your order of operations and how we use those in our head. But for now, make sure that you're focusing on these very specifically as multiplication or addition pieces. So when we use the commutative property, we're switching them around. So 7 and 9 are going to switch to be 9 times 7. When we have the associative property, we're going to keep those values the same, 4 times 6 times 5. We're going to move the parentheses from the 4 and the 6 to around the 6 and the 5. Let's do some multiplication with whole numbers. Suppose you want to find the product 7 times 65 by writing 65 as 60 plus 5. And then we're going to apply the distributive property that we mentioned earlier. So we would have 7 times 65, right? We're going to break it up into 7 times 60 plus 5. We're going to do 7 times 60, and then we're going to do 7 times plus 7 times 5. 7 times 6 we know is 42, and then you're going to add that 0 to get 420. Plus 7 times 5 is 35. 420 plus 35 is equal to 455. And if you weren't sure, you could add them up, making sure you line up your numbers to get your answer. If you're not strong with your multiplication, make sure you flip to your multiplication chart. You must memorize your multiplication numbers. Those are the only ways that you're going to get better and quicker at doing this math. I did not know 7 times 5 in a cinch. That would be something that I'd need to work on. Same thing with 7 times 6. We're going to do the same thing to 52 times 37 using the distributive property method. We're going to break up the 37. So we have 52 times 37. We're going to break it into 52 times 30 plus 7. So we have 52 times 30 plus 52 times, so 52 times 30, 52 times 7. Now, sometimes you might not know these factors right away. We're really going to do 52 times 3 and then add a 0 at the end. So 52, we're going to put a 3 underneath it and multiply. 2 times 3 is 6. And 5 times 3 is 15. So again, we go up and down first and then diagonally. So we have 156. Add a 0 to get 1,560. Don't forget that 0. Plus 52 times 7. So we do 52 times 7. Same method. We're going to go up and down first. So 2 times 7 to get 14. 14, so 1, 4. And then we do our diagonal. 7 times 5 is 35. Plus 1 is 36. So we get 364. Now we're going to add those two numbers together. Again, if it's not something that you can do in your head, you line up your numbers and then you add them together. 0 plus 4 is 4, 6 plus 6 is 12, 5 plus 3 plus 1 is 9, and 1 plus 0 is 1. So we get 1,924. So we've done it using the distributive model. We started using, this is what we call the vertical model. And that's the form that many students are more familiar with. 43 is the bigger number, 9 times 43. 43 being the bigger number is going to go on top, the 9 is going to go underneath. When multiplying, you're going to do the 9 times 3 first, and 3 times 9, because I'm going to do that first, is going to give me 27, carry the 2. The next step is 4 times 9 to get 36, and then you're going to add the 2 to get 38. There is a box method as well. And I know that some of you know how to do that box method, and I'm totally okay if you are comfortable using that method. I'm not going to teach that method. It's not in our textbook. The distributive model and the vertical model are what they're expecting you to know. If you want to use your box method, knock yourself out. If you're getting your answers wrong, please consider switching your methods. Let's look at the next problem. Example 10. We're going to multiply 279 times 428. We have 279 times 428. They have the same number of digits, so I'm going to just leave them. If you want to put 428 on top because it's a bigger number, that's perfectly fine. We're going to multiply, and we're going to do this set first. So 279 times 8, and that's going to be our first set. So 9 times 8 is 72. So I'm going to do 72. Then I'm going to do 7 times 8 to get 56, plus 7 is going to give me 63. And then 8 times 2 is 16, plus 16 plus 6 is going to give me 22. Okay, I don't want to get confused, so once I've used those numbers, I'm going to cross them out. Now I'm going to focus in on the next set. The next set is the 2. So we've finished with the 8, so I'm going to add a 0 for a place marker. And I'm going to start with the 2 and do the same multiplication from the 9, the 7, and then the other 2. So 2 times 9 is 18, carry the 1. 7 times 2 is 14 plus 1 is 15. And 2 times 2 is 4 plus 1 is 5. Then we're going to do the 2. We're done with the 2, so we need a place marker, and we'll do 2 now because we're on to the last number, 4. So we're going to do the same thing, 4 times 9, 4 times 7, and 4 times 2. So 4 times 9, oh, we didn't cross those off. 4 times 9 is 36. Notice that I'm starting underneath the 4. 4 times 7 is 28. Plus 3, 29, 30, 31. And 4 times 2 is 8. Plus 3, 9, 10, 11. And now I'm going to add them all together. 2 plus 0 is 2. 8 plus 3 is 11. Carry the 1. 1 plus 2 plus 5 plus 6. I'm going to count backwards. 6, 5 is 11, 12, 13, 14. I have 1 plus 2 is 3, plus 5 is 8, plus 1 is 9. And then zeros plus 1 is 1, 0 plus 1 is 1. So I get 119,412. Let's do some real-world application. A supermarket orders 35 cases of a certain soft drink. If each case contains 12 cans of the drink, then how many were ordered? So we have 35 cases of. Do you see that word of? Of meaning multiply. Of 12. So we have 35 cases of 12 drinks in each case. We have two ways we could solve this. We could do it vertical or we could do it distributive. So I'm going to show you the distributive model first, that 35 times the 12 broken into 10 plus 2. What is 35 times 10? And what is 35 times 2? A lot of you can do this in your head. Whenever you multiply by 10, you're just going to take the number 35 times 1 is 35, and then add a 0. 35 times 2, a lot of you know how to double numbers quickly. 35 plus 35, and I would get 70. And look at that, 35 plus 70. A lot of you, again, could do that in your head to get a total of 420 cans. If it's hard for you to think like this, you could still be practicing your multiplication of 35 times 12 using the vertical model. You could still have even done this one vertical, 35 times 2. Don't be afraid to do it like that as well. So 35 times 12, we're going to do 5 times 2 is 10, carry the 1. 3 times 2 is 6 plus 1 is 7. We're finished with the 2, we're going to make a place marker. 5 times 1 is 5. We've already used that. 3 times 1 is 3. Notice those numbers, 350 and 70, they're the same. 0 plus 0 is 0, we're adding them together. 7 plus 5 is 12, carry the 1. 3 plus 1 is 4. So again, we get 420 cans. Shirley earns $12 an hour for the first 40 hours she works each week. Okay. 12 hours for her first 40 hours. So we're going to highlight that. 12 hours in the first 40 hours. Interesting. She has $109 deducted. What does that mean? Deducted. That means subtract, right? So we have $109 subtracted from her weekly check for taxes and retirement. I want to know, how much does she earn? And she works 38 hours this week. So we are going to have to figure out if she has $12 an hour and she works 38 hours, so we're going to multiply. But then we have to take out her taxes of $109, her taxes and her retirement. So first step is multiply. We need to figure out how much does she make total. So what is 38 times 12? 8 times 2 is 16, carry the 1. 3 times 2 is 6 plus 1 is 7. We're done with the 2. We're going to leave a place marker, get rid of your extra numbers. 1 times 8 is 8. 1 times 3 is 3. We're going to add them up. 6 plus 0 is 6. 8 and 7 is 15. And 3 plus 1 is 4. So I know that she's making $456 that week, and she's taking out now $109 for her taxes and retirement. I'm going to now show my subtraction using the vertical model. And when I subtract, I notice that I have to borrow. So I borrow from the 5 and make that a 4, and this 6 becomes 16 when I add 10 to it. 16 take away 9 is going to give me 7. 4 take away 0 is 4, and 4 take away 1 is 3. So my answer is $347 if she works a 38-hour work week. In 1993, the government standardized the way that the nutrition information is presented on labels of most packaged food products. In Figure 1, one of these standardized food labels is from the original Cheez-It baked crackers. Approximately how many crackers are in the box, and what is the total number of calories consumed if all the crackers in the box are eaten? So this question actually has two parts. The first part is going to be how many crackers are in the box? How many crackers are in the box? Let's see if we can figure that out. So we know for crackers that in the box, we can see that there is about 27 crackers and there are 9 servings. So 27 in a serving and there are 9 servings. That means that I need to multiply 27 times 9. 7 times 9 is 63. 9 times 2 is 18 plus 6 is 24, and the answer is 243 crackers. So we answered the first question, but now we have the second question because there's an and here. And what is the total number of calories consumed if all of the crackers in the box are eaten? So we're looking at calories. So if we're looking at the calories, it is hard to read this, but it is 160 calories, and there again are 9 servings. So if we have 160 times 9, we're going to do 0 times 9 is 0, 6 times 9 is 54, and 9 times 1 is 9, plus 5 is 14. So we can estimate that there are 1,440 calories in the box. The table below shows the number of calories burned in 1 hour of exercise by a person who weighs 150 pounds. Suppose a 150-pound person will bowl for 2 hours after having eaten the box of crackers that we just talked about in example 13. Will he or she burn all the calories consumed from the crackers? So we're looking at this little table and we notice a couple of things. We notice that if we're bowling is right here. It's 265 calories burned, and we're doing this for 2 hours. Okay, so if we have 2 hours, and we're going to use bowling as our example, 2 times 265 means that I have burned how many calories? So we have 265 times 2. 5 times 2 is 10. 6 times 2 is 12, plus 1 is 13. 2 times 2 is 4, plus 1 is 5. So we have 530 calories burned. Now let's return to the question that we just asked. Well, the one that we just answered, too. Will he or she burn the number of calories from the crackers? Well, if you go back to your notes, we just answered that it was 1,440 calories. Will this be the same number to burn it off? And the answer is obviously no. If we have 1,440 calories eaten, and we subtract 530 calories that we just found are burned, we get an answer of 910 calories that we didn't burn off. So the answer is no. Obviously, this number is not big enough. He or she did not burn off the calories by bowling. Area. The area of a flat object is the measure of amount of surface area, the surface the object has. The area of a rectangle is calculated by multiplying the length by the width. The unit for area of square inches can be written as square inches or inches squared. So we like to write our equation as area is equal to length times width. We like to abbreviate as A equals LW. We could say in this example, we have 1, 2, 3 inches for the length, the long side, and then we have 2 inches for the width. 2 is in parentheses because we're going to multiply. We could say our answer is 3 times 2 is 6, and then we need to use one of these abbreviations. I'm usually going to use the inches squared. We're going to use that squared symbol to show that the inches are squared. So again, length, width. My apologies for the loud bird. Formulas to remember. Figure 3, so this figure here, there's 2 different formulas. Typically we're going to use the area equals length times width. Okay, or A equals LW. You can use this for rectangles or squares. But if you can remember this formula for a square, sometimes it can help later on in math. Notice that this one would be the side times the side for a square because they're all the same side. Or we would say A equals S times S, or that the area is equal to the side squared. You can use the rectangle formula for the square, it's up to you. In this math. In other maths, it might not be the same. Find the total area of the house and the deck, shown in this figure here. We have lots of different little pieces. We're going to try to figure out what the main pieces are, and we're going to try to put it together. So finding the total area of the house and the deck shown. You can see that there are a couple of different shapes. We're going to highlight out one of them. Here's one nice rectangle here. And to figure out what that one is, we need to figure out what each side is. So we could see that the side here is 9 plus 5 plus 17. And when we add those 3 together, we're going to get 31 feet. So that's the width. When we look at the length, we put these 3 together. And when we do that, we know the length is going to be 14 plus 23 plus 13. Add them up, and you get 50 feet. So if I wanted to find the area of the orange part, we know that that would be your length times your width. We know that the length is 50 and the width is 31. In this case, it may be easier to use the distributive model to figure out what your area is, or you could use your vertical model, we're going to do 50 times 31. So 0 times 1 is 0. 5 times 1 is 5. 0 times 3 is 0. 5 times 3 is 15. We add them up, and we get 1,550. And that's for your first one. That's for your orange one. Now remember, it wants the total area of the house and the deck. So because it wants and, that's add for total area. So we have the house. That's what we figured out here. And we know that the area of the house is 1,550. Now we need to figure out the deck. Well, how do you figure out the deck? Well, you need to kind of start by looking at the numbers for the deck. Let's see. We have yellow for this one. Here's your deck. We need to figure out what numbers line up with it. We should see that this 7 lines up with it right here. So we could say that this has 7 feet right here. And we actually have right up here, this piece is actually nicely sectioned off for us. So this part here across is going to be 13. So we know that for the deck, we have an area for length and width. The length is going to be 13 and the width is 7. So when we go to multiply, we have 13 times 7. 7 times 3 is 21. 1 times 7 is 7 plus 2 is 9. So we're going to take in our deck and add that in. When we look at these two numbers, when we add them together, we have 1,550 plus 91. We get 1. Carry the 1 for 14 because 5 plus 9 is 14. 5 plus 1 is 6, and 1 plus 0 is 1. So our final answer for the area of the house and deck is 1,641, and then we're going to look at the units. The units were feet squared because we're talking about area, and that's our answer. I want to remind you that if you were looking for around the house, if you were looking for that and you went around the house on the outside with the numbers, that's perimeter. Remember when we talked about that? And I think it was 1.2. Remind yourself that perimeter is not the same as area. Area is that multiplication, perimeter is adding. Solving equations. We have practiced this in adding, subtracting, and now multiplication. When solving for a variable, if n is used to represent a number, then the equation 4 times n equals 12 is read as 4 times n is 12, or the product of 4 and n is 12. This means that we are looking for the number we multiply by 4 to get 12. The number solution is 3. Because the equation becomes a true statement when n is equal to 3. We say 3 is the solution to the equation, or n equals 3. So 6 multiplied by what is 24? We would say 6 times 4 is equal to 24. So 4 is our answer. 15 is the product of 3 times n. So what number is n? We would say n is equal to 5 because we know 15 is equal to 3 times 5. Same thing in example 20. N is equal to what? when 21 is equal to 3 times n. N is equal to 7 because we know 21 is equal to 3 times 7. Again, practice your multiplication. There are plenty of websites that I'm going to link for you to practice your multiplication. I strongly recommend that you work with someone. If you have someone in your family that you can work on practicing this, encourage your family members to help you because this will help you be successful in multiplication of whole numbers. Again, this is 1.5, multiplication with whole numbers.